Okay, let's get started on our second part of Unit 4, Part 2, Inequalities and Systems of Inequalities. Today we are going to look at Day 5, graphing linear inequalities, and the next lesson we will have just one more element to look at. Okay, if you guys would turn to not page 5, Day 5, this is actually page 3 in this small packet. Let's define a linear inequality and then continue on. So a linear inequality is, first of all, it's an inequality. An inequality, and let me remind you there are really 4 inequalities. We have a less than, we have a greater than, we have a less than or equal, and we have a greater than or equal. So a linear inequality is an inequality involving 2 variables. An inequality involving 2 variables. So we are going to work with x and y because we are planning to graph these on a coordinate plane. Okay, before we jump into graphing, we are going to, on these first 2 examples, determine if each ordered pair is a solution. Now remember, a solution means 2 things. The first thing it means is if we were to plug it into the equation, it makes the, or in this case, inequality, it makes the inequality true. That also means if I were to graph it, it will be a part of the solution as far as our line goes. So let's, on these first 2, let's just simply plug in and see what we get. So let's plug in, we have 4 represents x and 5 represents y. So I'm going to substitute those in. We're going to check, is y, oops, back up, let's plug the 5 in. Is 5 less than or equal to 0.5 times x, which is 4, and then the rest of the inequality says 4. Is that true? Okay, well, let's do the math over here. So 5, is it less than or equal to? So 1.5 times 4, well, half of 4 is 2. 2 plus 4 is 6. So is 5 less than 4? Is 5 less than 6? Yeah. So is this a solution? Yes, this is a solution. Okay, I want you to move over to 2. Pause the video and try number 2. Okay, I substituted in and ended up with 6 is less than or equal to 1, and that is not true. Therefore, the ordered pair of -2, 6 is not a solution. Oops. Okay, so if we were simply testing a solution or not, we could just plug in the value and decide true or false. Okay, let's get into graphing here. So I have a lot of fill in the blanks here that I want us to do, and then I want to refer back to it as we start graphing. Okay, number 1, the steps in order to graph linear equalities. Number 1, first blank is graph. Okay, we are going to graph the equation of the line using the slope and the y-intercept, or we're going to use the x-intercept and y-intercept. So step 1, graph the equation of the line using the slope and the y-intercept. So think y equals mx plus b. Or we're going to use the x and y intercept. So we were going to plug the zeros in and calculate the intercepts. Okay, we get the line on the graph. Step 2, determine if the line or lines should be dashed. Okay, so they'll look like this. We'll have like dash, 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 and then maybe arrow on one side, arrow on the other. Or solid, which is what our typical line looks like, just a typical line. Okay, so we're going to be graphing. Sometimes we're going to put dashed lines or dotted lines. So we're going to make that determination. So in order to decide which is which, use a dashed line if it is a greater than sign or a less than sign, and a solid line if it's greater than or equal or less than or equal. So some people like to remember if it has the or equal bar under it, it's a solid line. If there's no or equal bar, it's a dashed. Okay, so we're going to get that done. We're also going to shade on these equations. So we are going to choose a test point. So we're going to pick an ordered pair. We are going to substitute this point into the inequality, similar to what we did above. If it's true, so if true, shade the area that includes the point. If false, shade the area that does not include the point. Okay, I am going to come back to this little asterisk here about if it's in slope-intercept form, okay, because this is one of those things that once you get the hang of the graphing and shading, what I have here is going to be a little bit of a quicker way to do it, but I want you to fundamentally understand the why behind it. All right, so let's move on to number 1. We are going to graph, let me change colors here. We are going to graph this inequality. Okay, so first thing I see, right off the bat, it's in the form of y equals mx plus b. So I can see that the m is 2/3 and the b is -1. Now remember, I am sometimes graphing a solid line or a dashed line. So I want to come back up here. This is a less than or equal. So what I want you to see is it's going to be a solid line since it's a less than or equal. Okay, so let's go ahead and graph. So start with the -1, and then the slope is 2/3. So I'm going to go up to over 3, up to over 3, and then I'll go the other way, down to over 3. Now, on this, when I graph inequalities, I like to try to fill the whole grid up left to right. Okay, and I just stop when I run out of room. All right, so this is a solid line. So we're going to graph it just like normal. Okay, so draw your line through. Okay, so since it's an inequality, there's more than one answer to this problem. There's an infinite number. So I want to shade in all of the answers. And what I'm talking about is I want to shade in everything that fits the inequality. Okay, so we are gonna plug in a test point. Now, if my line, unless my line is going through 0, 0, I'm always going to pick that point because I'm trying to plug in an ordered pair, and zeros are really easy to work with. So I'm going to go back to my inequality. Let's plug in 0 for x and y, and I'm just going to rewrite it. So y is less than or equal to. So 0 is less than or equal to 2/3 times 0 minus 1. So I'm trying to decide, is this true or false? Okay, so I have 0 over here. So let's do the math. Anything times 0 is just 0. So 0 minus 1 is -1. Okay, is this true or is this false? 0 is less than or equal to -1. No, 0 is bigger. This is false. So let's go back up here. I just did my test point. So if it's false, we are going to shade the area that does not include the point. Okay, so here's what I want to start with. For right now, I'm just going to put a dot here. Okay, I don't really need it on my graph. But what I'm trying to say is the 0, 0 ordered pair is on this side of the line. So because this is false, I want to shade in the other side of the line. So something like this. Okay. And what that means is any ordered pair I just shaded in, if I were to plug it into the inequality, it would make a true statement. Okay, so this is my graphed solution. All right. So I graphed it, decided solid or dotted line, and then I plugged in my test point and I shaded. Okay. Well, let's go on to the next one. Actually, what I think I want to do is stop the video here. I don't want to make these too long. So I'm going to record a second video, and I would like you to move on. If you want to try to move on before you watch the video, see how far you can get. Okay, but go on to the next video.